Hello, guys. Today is the fourth perspective video in a series of videos I'm making about how many different perspectives can be used to explain how the universe uses consciousness to explore and learn about itself. So it's titled Gravity Emerges from Information, a binary stereoscopic framework that could unify quantum mechanics and general relativity. However, it's about a lot more than that. We'll talk about mechanisms of life and mechanisms of a lot of other areas in science. And this is supposed to be a very laid back perspective that I'm going to go through it in a step by step fashion so it's as easy to understand as possible. So you can think of this, the most basic form of information, as binary information. However, this isn't necessarily zeros and ones. This could be the absence of energy. This could be the absence of matter, the absence of a wave. This could be anything, just the absence of it. This could just be white and black, as you'll see in future slides. However, all the zeros and ones represent is information. It's just a way that you can designate information so that fundamentally we can gain an understanding of how patterns evolve and emerge. And one way that these patterns can evolve and emerge that we know exists and that we can use to connect everything is stereoscopic channels. So stereoscopic channels create something called disparity, and that disparity helps us see depth in geometry. One real world example is comparing humans, our stereoscopic channels between our left and right eyes, to pigeons. Humans have stereoscopic channels in their left and right eyes that overlap a lot, creating binocular vision. However, pigeons have a panoramic field of vision since their eyes are on opposite sides of their head, so they don't have as much overlap. So they don't really see depth as well as we do. And that's why if you ever look at pigeons, they're always bobbing their head so that that movement can help create disparity and it can help them see depth and geometry. So that's a real world example of how disparity can create depth in geometry. However, I think that this mechanism is working on even more fundamental levels like electrons and other quantum particles, which we'll talk about later on. And it really is a very intuitive way to understand things like quantum superposition and quantum entanglement. So as this depth in geometry gets generated, it will create three-dimensional space-time, which is commonly called gravity, and that gravity is just how matter and energy is wrapped around this space-time, and whenever it gathers around this space-time, it creates things like consciousness and life. So disparity creates depth, depth generates geometry, and geometry becomes space-time. And in future slides, we'll talk about how time is generated out of this geometrical structure of space and how all these perspectives are embedded in this fractal landscape of space. So to continue, let's talk about the two different views of physics. You have the classical view and the quantum view. So two worlds, two logics, and one reality. The quantum reality exists at very small scales, far away from our senses, while the classical view exists in the realm that our senses exist in, so they're a lot easier to understand. The classical world represents space-time and general relativity, where quantum view represents entanglement, wave-particle duality, the uncertainty principle, and superposition. So the classical world is deterministic, local, realist, continuous. It has obvious cause and effect relationships, while the quantum world is probabilistic, non-local, because of superposition and entanglement, contextual, discrete, it's broken up into little bitty pieces we call particles, and it favors correlation over causation. You can think of the correlation as the two stereoscopic perspectives being combined. They're correlated. So two theories that both work but cannot be merged. The challenge of modern physics is to understand how these two descriptions of reality arise from a deeper unified foundation. Famous quote by Werner Heisenberg was, "Not only is the universe stranger than we imagine, it is stranger than we can imagine." And I think that's true because our imagination exists in the three-dimensional classical world described by general relativity. However, it is governed by the quantum world and quantum waves and superposition and entanglement, which isn't really accessed by our senses because it doesn't really matter for us for our survival if we can see the wave of a photon. What matters more is if we can understand how something flies through the air or a planet moves around the sun or the moon rotates around the earth. That's more helpful for us to understand, and that lies and is explained in the classical realm. So to continue, let's talk about classical and quantum from a mathematical perspective. However, I will try to give an intuitive explanation for this. So from a classical viewpoint, it's already assumed that you know wave 1 and 2. So you can think of these as two ocean waves coming together. You can measure how tall an ocean wave is and understand it as wave 1, and you measure another wave, and that's wave 2. And then when these two waves collide, you get wave 1 added to wave 2, and then you can square that outcome and get the square of sums. So that's the classical view, is just simple addition because you already know the information. However, the quantum view is a little bit more complicated than that because in the quantum view, you have to account for all the different probabilities that could have happened. For instance, did it go through slit 1 or slit 2 when you're talking about the double slit experiment? So in order to account for all of these possibilities, you have to square wave 1 and wave 2. So you don't really know which slit it went through. You have to account for those probabilities. And in order to account for those probabilities, we square wave 1 and wave 2. And then when you add wave 1 squared and wave 2 squared, that gives you the sum of squares, which you can think of as kind of a superposition between wave 1 squared and wave 2 squared. So you end up with this emergent structure. It emerges from wave 1 and wave 2. It's not simply just the addition of wave 1 and 2. It's the emergent structure that you get whenever you combine wave 1 squared and wave 2 squared. And the sum of squares does not equal the square of sums. like you can calculate in the classical protocol. So that is why quantum mechanics is different. It's because you have things like superposition and entanglement that are mathematically described as wave 1 squared plus wave 2 squared. However, you can just think about it as an emergent structure that you get to calculate the superposition or the entanglement of these two different states to try to account for all the different possibilities that could happen. So it's a way for the universe to just make sure the most efficient outcome happens. That's an intuitive way to think about it. So let's get another intuitive way to think about superposition and entanglement, and also a way to think about how electrons or fundamental particles can use stereoscopic channels to form entangled structures. So you'll hear on YouTube or in the news that two particles, when they're entangled, can be on opposite sides of the unit. When you change one, for instance, in the spin of an electron, simultaneously the other electron changes. And physics is coming up with all these different theories to try to explain how that can happen. The way that you can think about it that doesn't need information to move faster than the speed of light so that it happens simultaneously. You can simply think about it as one electron is the left channel, the other electron is the right channel, and how these two electrons are correlated is from the superimposed image that you get when you combine these two channels together. So that represents the superposition or entanglement. And if you change a little bit of information in one, then simultaneously how these two images are correlated will also change. So the correlation changes faster than the speed of light. It's not that any information needs to travel between them that fast, it's just the correlation changes. And this is a way to think about two electrons, but you can also use photons, or you can think about this as your left and right eye. And when you open both eyes, what you see is a superimposed image of what you're visualizing in both eyes. So that explains the stereogram and the power of correlation. If you change a random pixel in the left image, you destroy the 3D effect unless you change the corresponding pixel in the right image. However, altering the left image doesn't mechanically send a physical signal or shoot a laser beam across the page to alter the right image. The two images simply share a hidden interconnected correlation. This is what I just described. Therefore, observing the 3D object doesn't violate local causality. Similarly, quantum non-locality means that reality is woven together by deep structural cross-correlations that transcend individual localized objects. So we're connected to things way far from us because of this correlation, this quantum correlation. But that doesn't go against any laws of physics that we can understand from quantum theory. We don't need to imagine wormholes or anything because it is working through a mechanism similar to this intuitive diagram. So let's explain this mechanism a little bit more and try to understand emergence. So you have binary information. At the most fundamental level, reality is built from binary distinctions. And again, it's not that at the most fundamental level there's zero and ones. This could represent something there or not there, energies there or not there, matters there or not there, a wave functions there or not there. This is just representing what is there. Information is the raw material. Information splits into two complementary channels, just like your left and right eyes. So that offers two perspectives of the same underlying data, which can create new patterns from the disparity between your left and right eye, or just the two different perspectives that are interacting with this data. So the differences between the channels create disparity, information about relation and structure. Disparity is the birth of new information. So new information emerges from this disparity. And the three-dimensional geometry that emerges forms this three-dimensional geometric structure. So patterns become shape, shape becomes space. And that space creates space-time, which gives everything context through time, which we'll explain later. Geometry within relation creates the context of space-time. Events are located. Change becomes meaningful. Gravity is mass and energy tells space-time how to curve. Curved space-time tells mass and energy how to move. For instance, the sun will curve space-time and will create a gravitational lensing effect so that that space-time will actually bend light a little bit when it's moving close to the sun. So if we're visualizing a star that's right next to the sun, at least the light coming from that star, that light will actually bend a little bit around the sun, and we can measure that, and that was actually used to confirm Einstein's theory of general relativity. So waves, the power of relation. When two waves overlap, something new emerges. The whole is more than the sum of its parts. So that's the most important thing about emergence, is that you have new patterns that can't be described simply by the original data. So that's kind of the key to the mechanism of quantum mechanics when we talked about wave 1 and wave 2 squared. It creates a special type of interference which can render emergent geometry. So relation creates reality. Each image looks like random noise on its own, but together they reveal depth that is invisible individually, which can be seen when they're combined or superimposed, and you have disparity. Depth emerges from the relationship between the two images. Reality is emergent, not given. From binary information to gravity, the universe is a continuous unfolding of relational becoming. The deepest truth, the whole contains information that the parts do not. This is very important for studying emergence in biology so that you can understand things like consciousness. So let's talk about the quantum vacuum and how it's really not empty. The vacuum is a dynamic sea of potential. At the deepest level, empty space seethes with activity, constantly giving rise to quantum fluctuations that appear and vanish in the blink of an eye. Nothing is truly empty. This was explained to us by Heisenberg about 100 years ago in the Heisenberg uncertainty principle, which allows energy to borrow from the vacuum for a tiny moment. This is the formula if you would like to digest that math. This uncertainty is what gives rise to quantum fluctuations. And we know that this happens because of things like the Casimir effect, which is the vacuum creates a measurable force between two plates. So you can have two plates and make the space in between those two plates an empty vacuum, and you can measure the energy that's fluctuating between those two plates. The Lamb shift, which is vacuum fluctuations cause tiny shifts in atomic energy levels. And self energy. Particles interact with the vacuum and influence their own properties, which was shown to us by Richard Feynman in his famous Feynman diagrams, which he won a Nobel Prize for. The vacuum has energy, 0 point energy, permeates all of space. It is the ground state of all fields, a restless, ever-present source of potential. So you can think about this as the information, those zeros and ones, always fluctuating, looking at the emergent information in new perspectives and trying to combine it in a different way that is more efficient. So it creates a sea of fields. Every point in space is filled with quantum fields. Fluctuations or ripples in these fields. You have electromagnetic field, electron field, and quark field, and many other types of fields. And you have waves that flow through these fields. And what we call particles are just excitation values, so the highest points of intensity on these fields. So the particle is kind of like the top of the wave, if you want to think about it like that. So from the vacuum to everything, you have quantum fluctuations. Those quantum fluctuations combine and create particles. Those particles combine and create atoms. Atoms combine and create stars, planets, life, and you. What we call reality emerges from the deep, invisible activity of the vacuum. The vacuum is the ultimate connection. All particles, forces, and structures arise from the same underlying quantum vacuum. It is not nothing, it is the foundation of everything. So there is no such thing as nothing. Even if you have a complete empty vacuum, you still have quantum fluctuations, which is something. You have the formula for 0 point energy describing these quantum fluctuations if you would like to digest the mathematical formula here. And the implications of these quantum fluctuations are the vacuum may contribute to dark energy. New physics could unlock energy technologies. It suggests the universe is far more unified than we imagine. The vacuum is not empty space. It is the source of space, time, matter, and possibility because it is what connects all of space together. So let's continue and ask why quantum mechanics uses waves, because reality is relational, not separate, and so that new information can emerge. At the most fundamental level, nature does not deal in isolated particles, it deals in relationships, possibilities, and interference. So particles are waves. Both pictures are incomplete. Particles describe localized events. Waves describe extended possibilities. Quantum mechanics uses waves because nature is not describing what is, but what could be. So you have de Broglie's hypothesis, which is matter has wave-like properties. Every particle has an associated wavelength. So this is the mathematical formula right here. You have Planck's constant, P for momentum, and Planck's constant divided by momentum gives you the wavelength. So the deeper the reality, the more wave-like the behavior. And you can kind of think about that because Quantum particles, you can measure their wave behavior, but if you get so many of them together, like all of the particles that create a human being or all of the particles that create a planet, the waves interfere so much that it just creates a continuous, constant object. So you can think about the interference happening so much that you just have a continuous object. So each wave is a probability distribution, a map of possibilities. They exist together in superposition, meaning all possibilities coexist. When they interact, they produce new outcomes that neither could alone. So the interference creates emergent structure. So we can see through the double split experiment, the double slit experiment, which I referred to earlier. So particles sent one at a time build an interference pattern over time. And this only shows one slit, but you can imagine two slits right here. The particle behaves like a wave because it is exploring all possible paths at once. And usually this is done with two slits, but I think you can still do it with one slit, and the wave of this one particle will still even interact with itself. So why nature chooses waves? Waves can interfere. Interference creates structure, order, and new information. So you can have emergence. Waves encode relational information. The whole is more than the sum of its parts. That's also emergence. The universe is fundamentally connected. Waves reflect the underlying unity of all things. Particles emerge from waves. Particles are localized outcomes of deeper wave possibilities. So that's what I was referencing earlier, is that particles are just an excitation on the wave of a quantum field. So quantum mechanics doesn't use waves as a trick. It uses waves because that is how nature thinks. So let's move on to the universe as a network of possible paths. At every moment, nature explores all possibilities. The quantum state contains every possible way events can unfold. Interference determines which outcomes become reality for an observer. So we do not see all paths. We see the result of interference. The observed outcome is the pattern that remains. From choice to superposition, every decision point, every interaction creates branching of possibilities. So you can think of this kind of as the choices we make and the choices that have been made for us. For instance, we can make a choice on what we're going to do with our life and how that might perpetuate through time and change the existence in the future. However, we can't choose to be made out of anything except atoms. Atoms in the universe were made long before humans were made. So that choice has been made for us. But that kind of proves that the universe does make choices. It's not just humans that do that. That choices are made at all different scales in existence, which we'll get into that a little bit more later as well. So all paths exist in superposition. None are chosen yet. That's referring to the future, and our choices will dictate that future. If you're interested in free will, that should tell you a lot. The quantum path integral. The universe follows every possible path and sums their contributions. Again, if you want to digest the formula, it's given right here. Each path has an amplitude, a path with a magnitude and a phase. Interference shapes reality. You have constructive interference and destructive interference. Just like when two big ocean waves come together, it makes a bigger wave that's constructive. When a big wave and a low wave come together, it's going to create it's going to bring down that bigger wave, and that's destructive interference. So paths can reinforce each other, and paths can cancel. So constructive interference can make some outcomes more likely, and destructive interference can make some outcomes suppressed. From the tiny to the cosmos, or the cosmic, the universal, the huge, the subatomic, electrons explore many paths. Atoms and molecules behavior arises from quantum possibilities. Chemistry and life, complex structures emerge from quantum roots. Consciousness, awareness rides a wave of possibilities. Cosmic evolution, galaxies, stars, planets all emerge from quantum potential. So you have observers that are entangled with these outcomes. Each observer follows a consistent path. You experience one path, but the whole exists. So our life, the choices we make in our life will perpetuate in the future as which outcome is selected. You experience one path, but the whole exists. What the network represents, nodes in the network that you can see right here, moments of interaction where possibilities branch and you have interference, links, possible paths through quantum states, amplitude, weight of each path, phase, how paths align and interfere. The universe is not a line, it is a living network of possibilities. Reality is not what is fixed, but what emerges from the interplay of all that can be. Nature doesn't choose a single path, it explores them all and lets interference write the story. It lets us write the story. So now let's explain how an intuitive way of thinking about this, how all this is connected by percolation theory, how possibility becomes reality. In a sea of possibilities, connected paths can span the whole system. When the network percolates, a giant cluster emerges. Reality becomes connected. The universe as a network of possible paths. Every point is a state. Every link is a possible transition. The lattice of possibilities, which is shown in gray in all of these pictures, showing the percolation transition. A simplified model of the multiverse of possibilities. So a possible state would be right here, the gray ball, and possible connection would be anything in between those little gray balls. So one way to think about this, the transition from nothing being connected to something in the whole system being connected. You can think of this about bubbles percolating in a coffee pot, or you can think about forest fires in a forest. At first, you just have a few bubbles or a few little fires in the forest, and then as time goes on, it gets connected more and more and more until a whole structure percolates throughout the whole system, so the whole forest becomes inflamed, or the coffee pot has bubbles all at the top of it. So that is percolation. When you start off with little bitty spots, and as more percolation occurs, everything gets connected. So the order parameter explains that the size of the largest cluster relative to the system jumps from near 0 to near 1 at a critical threshold. So you can think about this as you just have a few nodes connected right here, just a few spots are percolating. But once you cross this critical threshold, then immediately many nodes start connecting together until very quickly the whole system is connected. And you see this critical point happens in biology. It happens in the organization of solar systems and planets and stars. It happens in galaxy clusters. It happens at many different scales throughout the universe. A consciousness can be explained like this, where at first you have a few thoughts that aren't really connected, but as you learn more and more and more, eventually you reach a critical point where all of those thoughts get connected, and all of a sudden you have a new emergent idea because there's a whole new structure that has been created in your brain. So moving, and we'll talk about how it explains biology, specifically biomolecular condensates, in future slides. So percolation in the universe of possibilities, the quantum vacuum, is a network of potential states and transitions. As interactions turn on, increase in probability, the network approaches a critical point. So you have the quantum vacuum, which is mainly isolated possibilities. It approaches criticality, so fluctuations build connectivity. And then you have percolation, the universe becomes one. So the quantum fluctuations is what connects everything together, given time. So why it matters, explains emergence, global order from local rules. It explains phase transitions like liquid-liquid phase separation in biology. Its sudden shifts in connectivity. Explains structure, why the universe has large-scale coherence. It's coherent in many different scales of reality. You have this same structural organization that's occurring, and it explains us. We exist because the network percolated. Below the threshold, possibilities are isolated. Above the threshold, possibilities become reality. The universe did not just happen, it emerged when the network of possibilities percolated into being. The universe as a network of possibilities. Let's talk about gravity, the emergence of geometry from connectivity. So gravity isn't really a fundamental force, it is an emergent force. Gravity is not a force pulling in empty space like was described by Newton. It is the emergence of curved geometry from the pattern of connections in the network of possible paths that Einstein called space-time over 100 years ago. So from possibilities to geometry, the denser the connections, the more the network offers easier paths through. This shapes the geometry that emerges. You have sparse connections, you have flatter geometry, and whenever you have dense connections, you have curved geometry, like the space curved around the sun or the space curved around Earth. Objects follow geodesics. In a curved network, the easiest, most connected path appear curved. This is how planets orbit. Light bends. Like I said, light bends when it's moving around the sun. And objects fall naturally. They're just falling along this curved space. Light bends because paths bend. Light takes the easiest available path in space. Curvature changes the path. A flat network is a straight path, but you can imagine that there's no big massive object here. But when you have a big massive object here, you have a curved network, which creates a bent path, like the light moving around the sun. So you have equivalence, the mass equals curvature. More mass or energy, more connections, more curvature. The network does not distinguish between them. Add mass and energy, connections densify, curvature increases. So dense connections curve the network, curved networks guide motion. And that's the framework that everything exists in: galaxy clusters, stars, black holes, planets. So let's talk about black holes a little bit. You have extreme connectivity. At extreme density, connections become so intense that no path leads back out. Not a surface, a phase of connectivity. Information is not destroyed, it is transformed. And we'll talk about how time is affected by black holes in future slides. The network view unifies gravity. It explains orbits, tides, lensing, and cosmic structure, naturally connects quantum and cosmic scales. No separate force, no curved space, only connections, only emergence. Gravity is emergent. Mass and energy increases local connectivity. This changes what paths are easiest to take. So the easiest path in a flat network and the easiest path in a curved network. It's following that space. Objects follow the easiest path. These are geodesics of the network. We call this gravity. Gravity is how matter is falling along this space-time, this geometry. Space-time is an emergent network. Space-time is not a stage. It is a pattern of relations that emerges from quantum connections. So again, quantum connections, emergent space-time, and gravity as we experience it. Gravity is not fundamental, it is inevitable. Given a network of possible paths, gravity must emerge. Where connections go, geometry follows. Where geometry emerges, gravity is what we feel. The universe is not held together by gravity, it is held together by relation. Gravity is what relationship feels like when you are inside it. So now let's talk about Hilbert space, entanglement, and informational geometry, the mathematical language of possibilities. At the deepest level, the universe is not just made of matter or energy. It is made of information, which can create patterns. These three ideas show how possibilities become reality. So all the different realities in quantum mechanics are explained by Hilbert space, the space of possibilities. Every quantum system is described by a state vector in an abstract space called Hilbert space. A state is a superposition. Measurement collapses possibilities into outcomes. And entanglement is the connection beyond separation. So it's emergence. When systems interact, their states become entangled. They can no longer be described independently. And at the end of this, I'll give a very intuitive way you can think about all this. So measuring A instantly influences B, no matter the distance. We explain this through stereoscopic channels combining to create a superimposed image. Correlations exist without a classical communication. The whole contains information not present in the parts. Informational geometry, the shape of knowledge. The set of all possible states has a geometry. We can measure distance, angle, and curvature based on distinguishability. The Fisher information metric measures how quickly states change. Distance reflects how different two states are. Curvature reveals constraints and resources. Geodesics are the most efficient path of change. Information is geometry. Geometry is reality. So you have Hilbert space is the stage where all possibilities exist. Entanglement weaves a network of connections across the fabric of possibilities. Information gives the universe a shape. Geometry guides what can happen. So this just kind of goes over what I just explained. And an intuitive way you can think about this is you can think about the Hilbert space as your imagination, how your imagination connects things, which eventually makes new emergent patterns. You can think about as entanglement, and then how your imagination ends up connecting things in reality and guides your behavior, creates the real life that you live in the universe, which is the informational geometry. So you can think about it as consciousness is entanglement, Hilbert space is your imagination, and then what your reality is how your imagination is thinking about things through consciousness and connecting new things in reality so that you can pave a way, you can pave a path for yourself in the future. So the universe has information. Reality is not built from things, but from relational information, like the information that your imagination is trying to combine and connect throughout your consciousness so you can have a better and better idea of yourself and others and what you can do with your life. Hilbert space holds the possibilities, entanglement links them, geometry shapes them. Existence is information in motion. The universe is a geometric network of informational relationships. To exist is to be connected, to evolve is to move through possibility. So continue, we'll talk about gravitational waves, ripples of geometry, carriers of information. When massive objects accelerate, they disturb the fabric of space-time. These disturbances are what we call gravitational waves, travel across the cosmos, carrying information about their origins. So what are gravitational waves? Gravitational waves are ripples in space-time generated by accelerating masses. They propagate at the speed of light. They stretch and squeeze space-time perpendicular to their direction of travel. So this gives you an idea of how it works, the direction of propagation, and how it can bend the points that make up space-time. So from cataclysmic events to cosmic messages, when you have supernova or neutron star collisions or black hole mergers, these all create gravitational waves. And we can actually measure that at laser interferometers like LIGO, which there is one laser interferometer in Louisiana. I'm shooting this video in Louisiana right now, so I had to give a shout out for that. And LIGO detects incredibly tiny changes in distance using lasers. And these distances can be smaller than a proton. So what changes does it detect? It detects a passing gravitational wave change, which changes the length of the arms ever so slightly. So it changes the distance in between these laser beams. And they use multiple places on Earth that has these detectors so they can triangulate the signal and they can see exactly where in the universe this is happening. This shifts the interference pattern at the detector. And again, you can look at the formula here if you want to digest that. So you have historic detections given here. So you can think of a waveform as information. The shape of the wave tells us about mass, spins, and the nature of gravity itself. In Hilbert space, waves are states. Gravitational waves are represented as quantum states in a Hilbert space of geometry. So the basis states different possible geometries, wave packets, localized disturbances, and the evolution governed by Einstein's equations are linearized for small perturbations. Entanglement of geometry. Gravitational waves can become entangled with matter, fields, and even other regions of space-time because information is not local. Correlations reveal more than classical signals. Informational geometry perspective. Each possible geometry is a point on a manifold. Gravitational waves trace paths along geodesics. So the curvature tells us how information changes. Why does this matter? For one, it explains how everything, even the large-scale objects, are all connected and how what they do can be directly correlated to the quantum perspectives that we're talking about. It's a new window on the universe. Gravitational waves reveal events invisible to light. It tests gravity. Einstein predicted this over 100 years ago, so it's testing general relativity. Quantum gravity clues. Gravitational waves may carry signatures of the quantum nature of spacetime. Information in motion. They are not just ripples, they are messages from the geometry itself. So gravitational waves are not just disturbances, they are informational currents in the fabric of reality. In Hilbert space, they are states. Through entanglement, they connect. Through geometry, they reveal. The universe speaks in the language of waves, information, and geometry. Geometry as a quasi-particle. This is just an easy way to think about gravity and how gravity is just the geometric connections of many different points in space, similar to how a quasi-particle is the geometric connections between many different particles or atoms. So what is a quasi-particle? In many systems, collective excitations behave like particles, just like a wave moving through a crystal, which is called a phonon. They are not fundamental, but emerge from the underlying degrees of freedom. And you have these examples here. Quasi-particles carry energy, momentum, and other quantum numbers. So gravity as a quantum of geometry. General relativity describes gravity as curvature of spacetime. In a quantum theory, small ripples of this geometry should be carried by quanta, that's called gravitons. So you can think of these gravitational waves as in the same sense, or in the same way as a wave moving through a crystal, and all the atoms in the crystal would represent different points in space-time. A quasi-particle view of gravity. At low energies, gravity may behave as if mediated by gravitons, just like other forces are mediated by gauge bosons. So you can see the forces and what they could be mediated by. But again, we're not explaining this as gravity as a force, it's just emergent. So I don't really think that the graviton exists, but it is a intuitive way that you can think about gravity. So in this view, gravitons are not fundamental objects, but effective excitations of a deeper quantum structure of spacetime. Like phonons in a crystal, gravitons are ripples in the fabric of a more fundamental medium. That medium is information. So where could gravitons come from? If space-time is emergent, gravitons may arise from collective behavior of microscopic degrees of freedom. Predictions: if gravity is a quasi-particle, gravitons self-interact. Quantum corrections to Newton's laws at very short distances. Gravitational waves show quantum features at extreme scales. Lorentz invariants may emerge, not be fundamental. These effects are tiny but may be observable in future high-precision experiments or cosmology. So maybe one day we can test to know for sure if gravity is emergent. However, Einstein's theory of general relativity pretty much explains that already, I think. The big picture: at macroscopic scales, we see smooth spacetime and gravity. At microscopic scales, that smoothness may be an illusion, like temperature emerges from molecular motion. Gravity may be the lowest energy whisper of a deeper quantum world. Gravity as a quasi-particle, not fundamental, but real, not primary, but emergent. So gravitational waves mediated by disparity structures reorganize collectively. So this is going to give us a framework to think about time. This is explaining the fabric of space-time, a field of disparity structures. Space-time at the fundamental level is composed of disparity structures, relational differences between possibilities. Disparities give rise to geometry. Geometry is the large-scale pattern of how disparities are arranged. Mass creates disparity gradients. Mass and energy concentrations impose boundary conditions that skew the distribution of disparities, creating gradients. So whenever you have mass, you have more disparity. Changes travel as reorganization. Distributions in the disparity field do not propagate as particles, but as collective reorganizations of the network. This reorganization is a wave, like a gravitational wave, moving through space-time and reorganizing and adding a new perspective for all the information that it's moving through. Gravitational waves, disparity waves. Gravitational waves are coherent, propagating reorganizations of disparity structures across vast regions. The wave is not in space-time. Space-time is the changing pattern. So the mechanism is you have a cataclysmic event like merging black holes or neutron stars colliding together. You have a rearrangement of local disparities. Collective reorganization spreads outward. Coherent disparity wave forms. Wave travels across the disparity network, and detectors like LIGO can detect these changes, which is shown right here. So why this view? It explains gravity is universal and how everything is connected, and the fact that we've measured that connection on Earth. So all disparities are connected. Explains why gravity is weak. Reorganization is diffused across an enormous network. Explains gravitational waves. Changes propagate as patterns, not particles. So what carries the waves? Not particles, not fields in the traditional sense. It is the connectivity pattern itself that shifts collectively. The medium is relational information. The message is change. An analogy is: imagine a stretched net of interconnected springs. That would be disparities. Pluck a region. The disturbance is not a ball moving across the net. It is the net reshaping itself in a wave. So that explains gravitational waves very well. The deeper implications are that gravity is an emergent phenomena from the collective dynamics of disparity structures. gravitational waves are the universe's way of updating its relational architecture. So gravitational waves are not particles, they are patterns of collective reorganization in the network of disparities that gives rise to space-time itself. So I told you that this was going to be a framework to intuitively think about what time is, since general relativity explain that time is relative. We'll explain a way to think about it on this slide. So integrated information, the basis of reality. Information is not just stored, it is integrated. The more a system integrates information, the more real and unified it is. Measure how much information a system has above and beyond its parts. That is integrated information, which is given by the symbol phi and used by Schrodinger to understand how a quantum wave can move through a system and propagate. The universe favors states that integrate information. So relative time, change without a clock. You have to remember that clocks just measure time. They're not what time is. Time is not fundamental. It emerges from change, measured relative to other changes. So you can imagine it as changes in this geometry. But in some places, like where you have a lot of gravity, gravity constrains that geometry, so time moves a little bit slower. But other places that aren't experiencing as much gravity, time moves a little faster. We know this is happening because we have to account for this on our GPS systems. The GPS satellites are experiencing time at a split second faster rate than we're experiencing time on Earth, because close to Earth we have more gravity. So we have to account for that so that we can render a useful map created by our GPS systems. So we know that this happens, and this was predicted by Einstein's theory of general relativity. So time is the ordering of changes in A relative to changes in B. No absolute time needed, only relations. Because like I said, you can have two different places, like on Earth or a satellite, and the rate of change of geometry on the satellite compared to on Earth actually creates the differences of time. So time emerges from the network of informational changes. Informational geometry, the shape of possibilities. The set of all possible states has a shape. Distances and curvature reflect how distinguishable states are. And you have an informational metric here if you would like to digest that math. Geometry is not background, it is derived from distinguishability. Distinguishability. Sorry. So integrated information. Systems integrate information into unified wholes. Relative time. Change is observed relative to other changes. Informational geometry. The space of states has a geometry shaped by information. Reality emerges from integrated information, relative change, and georelations. So the key insights are information integrates, change is relative, geometry emerges. Reality is information. Examples of integrated information: when you have low integration or low phi, parts act independently, little to no integration. High phi or high integration, parts constrain and information and inform each other, so unity emerges. Integration creates new causal power. The whole does more than the parts. So again, this is emergence. Emergence of relative time. No clock, just changes compared to other changes. Order arises from correlations. System A, system B. When A changes, then B changes. A experiences time relative to B, just like Earth and a satellite. Geometry from information. The metric comes from how states can be distinguished. Flatter regions, states are easy to distinguish. Curved regions, states are hard to distinguish. Curvature equals informational constraint. It guides the natural flow of change. So this is what time is. This is the expression of time. So the implications for consciousness are that high integrated information correlates with unified experience. For time, time is not fundamental. Just like gravity is not fundamental, what's really happening is this connection of possibilities, this connected geometry that we call space-time. So it's emergent and observer dependent. And what is physics? What does it say about physics? The laws describe consistent patterns in informational change. So, three pillars of informational reality are integrated information, relative time, informational geometry. So, integrated information creates unified systems. So that's what is real. Relative time is the order of change or rate of change, how it unfolds. Informational geometry shapes possibilities where it can go. The universe is a network of informational relations. That is all that is needed. So that gives you a framework to think about time as a change of geometry. So all time is how the geometry that makes up space-time changes. And a clock is just what measures that rate of change. So let's think about this from a space-time perspective. So the geometry is not flat. The space of all possible states has curvature. The curvature comes from how hard it is to distinguish between states. So curvature equals informational constraint. Change flows along geodesics. The natural path of change is given by geodesics. Path of steepest, least resistant informational change. Let's give an example, a very intuitive example. A journey through the geometry. Two travelers take the same path. Traveler A has a flat region, traveler B a curved region. A's clock shows more time has passed when they arrive. Change flowed faster along A's path. Same distance, different time. B's clock shows less time has passed. Change was resisted by curvature. So it's the same distance right here, but you have more curvature right here for B than you have for A. So B experiences time at a slower rate. And you can think about how this is happening by thinking about the oscillation of atoms, for instance. Everyone is made up of atoms. So, and all those atoms are constantly oscillating. So whenever you're moving through curved space, the oscillation of those atoms gets slowed by the curved space because that oscillation and that movement has to account for and render itself in this new curved space at a higher rate than it would if it was going through flat space. So the curved space constrains how time is passing through every atom because that atom has to pay attention for how it renders itself in that new space since it's curved. But if it was just going through a more linear straight path, then it wouldn't have to put all its energy to render itself in a new type of space. and it would continue to oscillate at the same rate, and that's why time would be moving at the same rate, where in curved space, time is moving a little slower. So I hope that made sense to you. That explains how the curvature of space-time slows the rate of change, which we call time, by constraining the geometrical framework that matter and energy is within. So the big picture. Reality is a dynamic, informational geometry. Change is the fundamental flow. Time is the local measure of that flow. Information is encoded in states. Geometry shapes how change flows. Time emerges from the local flow of change. So time is how change is experienced locally in the geometry. So cosmic evolution is not uniform. Some regions of the universe age faster than others. You can think about if you're standing right by a black hole, the geometry would be constrained a lot more than on Earth. So if you stand by a black hole, you're experiencing time at a lot slower rate. So if you would travel back to Earth, time will have passed way faster on Earth than it would have for you close to that black hole. Gravitational time dilation is a direct result of geometric slowing of change. Information processing speed varies across the fabric of reality. I'm sorry for being a little bit redundant here, but some of these concepts are very hard to wrap your mind around when you come about them for the first time. So I think redundancy is a little helpful for some people in this circumstance. So the key insights is that different regions of the geometry evolve at different rates because curvature changes the flow of information. Where it's easy to change, time runs fast. Where it's hard to change, time runs slow. The universe does not tick, it unfolds. Its rhythm is the geometry of information becoming and emerging. So now let's talk about my favorite part of the presentation, and that is biomolecular condensates life and the scaling of organization. From molecules to minds, organization emerges by the same principles that shape the universe: information, interaction, scale, emergence. What are biomolecular condensates? Cells are full of dynamic membraneless compartments formed by phase separation, specifically liquid-liquid phase separation. They concentrate molecules, accelerate reactions, and organize biological processes. Examples are the nucleolus, which is inside the nucleus, the stress granules in the cytoplasm, P bodies, Hodgel body, I think that's how you pronounce it, and the synaptic density between the neuronal synapses. You also have galectin-3 condensates, which I've researched a lot, which are outside of the cell. Well, really, they exist everywhere in the nucleus, in subcellular compartments in the cytosol and outside of the cell. But what's not talked about is the galectin-3 condensates that exist outside of the cell, and I think those are important because they organize fibers like collagen and fibronectin and laminin, which mediate the structural patterns of tissues. And they also mediate things like cancer metastasis and how the cancer cells can utilize these galectin-3 condensates to manipulate the framework, the tissue architecture that they're within so that they can metastasize. So that's very important to understand when you're trying to treat metastatic cancer, because those condensates can not only manipulate the structure that the cell's in and allow for that metastasis, but they can also manipulate the receptors so that the cells can form resistance to anything we try to treat those cells with. So they're very, very important for trying to treat cancer. And these condensates are dynamic, reversible, functional. Condensates are not static structures, they are active states of matter. And they also follow the percolation theory. So the way these condensates form is when you just have a few proteins together that they are starting to interact and trying to form a condensate. You can think about it kind of like this, but then when you reach that critical threshold and enough proteins come together, then you rapidly have a phase transition or a phase separation of this condensate, and you have boundary conditions of water within water. So it's a way that the cell can create boundary conditions to separate information inside of water. So this has implications for the origin of life, because one question is, how did the first forms of life that didn't even have a membrane come together and form boundary conditions so that biochemical reactions could start occurring? And this explains it. If you would like to read more about that, you can find my paper online titled Liquid-Liquid Phase Separation as a Driver of Abiogenesis and Evolution. And it not only explains the origin of life through liquid-liquid phase separation, but it also explains how that continued to be a way that life organized information and created boundary conditions to subsequently create all the life forms you see on Earth today. So it's a good paper, check it out. The physics of phase separation. So you have multivalent interactions plus disorder equals phase separation, like oil droplets in water. However, what we're really talking about are condensed phases of water with biological molecules in water. And those biological molecules come together through multivalent interactions. These multivalent interactions are hydrogen bonding, hydrophobic bonding, and electrostatic bonding. So these are just different ways, different intermolecular forces that chemicals or biological compounds can come together. So you have intramolecular forces, which are covalent bonds. For instance, in water, everyone knows it's H2O. So two hydrogens are directly bound to an oxygen, but those hydrogens have a slightly positive charge, and that oxygen has a slightly negative charge. And those charges can kind of stack among one another through intermolecular forces to combine in different configurations. So these are called intermolecular forces, and the way that these intermolecular forces of water interact with the intermolecular forces of biological molecules like proteins, DNA, and RNA. These intermolecular forces between water and these biological molecules can create phase separation and organize itself and create boundary conditions inside of water through liquid-liquid phase separation. And these are reversible and dynamic, so it's a perfect way to constantly adapt to the environment. So these are weak multivalent interactions, no membrane required, only information in the network. So you can have a whole network of these biomolecular condensates through liquid-liquid phase liquid-liquid phase separation. So information and condensates are information processors. Since they're dynamic, things are constantly coming in and out, and some things or biological molecules that are coming in and out are making the condensate stronger. Some are making the condensate weaker, which can diffuse. So you can think about this network of biological condensates constantly rearranging itself and moving. And that's why it's a great explanation for consciousness. It doesn't totally explain consciousness, but it gives a perfect framework for consciousness, and that's why it's part of the synaptic density, because you can think of whenever you have new thoughts and new electrical signals going through your brain, it's making many different millions of different condensates in your brain either get stronger or get weaker, and some of them will dissolve. So this is the dynamic processing system of your consciousness in your brain, but it's not just happening in your brain, it's happening in all cells and in all of life on Earth. So it's very, very interesting. So the condensates transform information flow into function, just like one function you can think about is the way these condensates combine together with receptors on a cell and the fibers like collagen and fibronectin. The way those condensates form those structures is what inevitably leads to the structure of the tissue, and that happens to remodel all the different types of tissue, but it's also what cancer takes advantage of to metastasize. However, this mechanism of cancer isn't only used for cancer, it's also used for things like healing and embryogenesis when cells have to move around and reorganize to fix a wound or make a new morphological structure. So, from chemistry to biology, condensates enable life by organizing complexity without needing new components. So, from molecules, you have intermolecular interactions, and those intermolecular interactions between those molecules form condensates. Those condensates form networks in cells. Life is not just about making molecules, but about organizing them at the right scale. So the scaling of organization emerges across many scales, each level built from the one below. Again, you have molecules, macromolecules, condensates, cells, organisms, and societies. Each scale emerges from collective interactions at the scale below. So you can think of all your cells as different perspectives combining together to create an organism like humans, and a lot of different condensates connecting together to create a cell. And at each different scale, you have a different perspective coming together, different perspectives coming together. And obviously, the larger scales are more integrated. So the universal principle across scales, the same rules govern from proteins to planets. You have information in cells. This information is sequence, structure, and modifications. In life, it's genes, signals, memories. In the universe, it's fields, geometry, information. However, this is all intertwined. The interactions, you have weak multivalent binding in cells or condensates. In life, you have communication and feedback, like ants in a colony or humans in society. In the universe, you have forces, curvature, and relationality. You have self-organization at all scales. You have self-organization in liquid-liquid phase separation, which creates patterns in cells and tissue patterns. In life, you have development and adaptation, and in the universe, you have structure formation and cosmic evolution. So the emergent structures formed through this in cells. You have function from collective behavior. You have in life, you have consciousness and intelligence, and in the universe, you have space-time, gravity, and observers. Different scales, same story, information plus interaction plus scale equals emergence. So you can think about this framework of liquid-liquid phase separation as being a perfect framework for explaining the neutral evolution or adaptive mechanisms of life because condensates form, dissolve, and reorganize in response to the environment. Life is adaptive information flow through dynamic organization, defined by the dynamics of these water droplets forming through liquid-liquid phase separation of biomolecules within water to create boundary conditions. So this matters because it bridges physics and biology through shared principles, explains how complexity emerges without extravagant components, suggests life is not rare, it is what happens when information is organized at the right scale. So this gets into astrobiology. We are not separate from the universe, we are one of its ways of becoming. From quantum fields to human thought, the universe builds itself by organizing information. Life is the universe knowing itself in local adaptive forms. So this brings us to a fractal universe of collective organization. From simple information to conscious observers, nature builds layers of organization. At every scale, parts become a whole. The same pattern repeats. You have information, which through different perspectives creates fields. The fields combine through interference to create particles. The particles combine to create atoms. The atoms combine in covalent and non-covalent ways to create molecules and macromolecules. The macromolecules combine in intermolecular forces that's non-covalent to create biomolecular condensates. Those condensates create informational boundaries and networks which organize different biomolecules together to create cells. Those cells organize to create organisms. Organisms create societies, and societies create civilization. It's a self-organization that repeats at every scale, from galaxies and nebulas within galaxies to star systems that contain planets. Planets contain ecosystems. Ecosystems contain organisms. Organisms are made of cells, and the cells, the information processing of our cells and the information we receive from the environment creates our brains and our minds and our consciousness. Each level is a world to the level below it. Each level is a part of a larger whole above it. So there's principles of fractal organization, emergence, scale relativity, information integration, self-reference, and coevolution. Components shape and are shaped by the whole. And we went through all of these in different slides. The universe is a living hierarchy of collective organization. We are both a whole and a part. Perspective across scales. From our scale, atoms are too small to see and cells are too complex to build from scratch. From the cell's scale, we are too large to comprehend. From a higher scale, our civilization may be a tiny part of a larger mind. Reality is not built from isolated things, but from relationships. The pattern repeats. The whole is more than the sum of its parts. That is emergence. So this is the best single diagram to explain everything I'm trying to elaborate on here and describe. So this shows the U loop and the scaling of consciousness. So does the U represent the universe, or does the U represent us, describing all the different forms of consciousness that is being generated in existence? So you can think about how all of these different perspectives are connected. You can think of the lowest level, maybe an electron, and there's many papers written on how an electron can be described as having its own consciousness, its own perspective that's being correlated with other perspectives. You can think of higher levels being condensates or molecules, atoms, cells, and as you get higher, you have humans. And then there could be something even higher than that, that some religions call God or a higher power, or the, frequency of the universe, or the, cosmic Godhead. There's many different um, ways of thinking about the consciousness that exists beyond us, but I don't think it is so silly to think that way. And the reason why I think that is because I'll give an example, but there's many examples of perspectives that exist at scales below our own, but a good one is mitochondria. Mitochondria have their own DNA. And we know that if you go far back enough in time, they came into animal cells and created animal cells from an alpha proteobacteria. So if you go back 2 billion years, mitochondria were actually bacteria. And we know that because they have their own circular DNA, amongst many other ways of figuring that out. So we have to have mitochondria for oxidative phosphorylation and metabolism in our cells. And it's what gives animal cells the ability to create all the beautiful types of animals that we see on Earth today, all the different structures. So that mitochondria is vital to our existence. However, in a way, it's its own organism. It has its own DNA and probably has its own perspective, and it communicates with other mitochondria. So it has its own perspective, its own information processing, even without any knowledge of our goals, and probably that it's even a part of us. So you can think of our existence as a mitochondria that's part of a bigger living system, and that humans are just one small part, but a very meaningful part, just like the mitochondria is vital to our life and creates and allows animals to create all kind of different patterns that emerge throughout time. Humans create new things and new environments that emerge throughout time, but we are still part of a bigger living system. So that bigger living system would be the biggest you that exists. And it's all connected. It's all just different perspectives trying to learn and understand itself. And it's all connected in this fractal organization of information. So for the closing, a universe that learns to know itself from the tiniest quanta to conscious civilization, nature builds reality by organizing information. At every scale, relationships create new possibilities. The whole is more than the sum of its parts. Emergence is the new realities that arise when parts interact and self-organize. The self-observation systems become aware of themselves and their place in the whole. Information is the raw potential of reality. Relationship is the creative power that shapes it. From cosmic scale to planetary scale, biological scale, cellular scale, molecular scale, quantum scale, and even down to the bits and pieces at the informational scale, is a fractal hierarchy of observers and perspectives. Our role in the universe unfolding. Curiosity connects us, collaboration amplifies us, understanding transforms us. By aligning with truth, beauty, and compassion, we help the universe know itself more deeply. Consciousness is the integration of information across scales, gives rise to experience. We are the universe becoming aware of itself. Beyond us, if the pattern continues, greater forms of awareness may exist, just as we are greater than the cells and bacteria within us. However, those cells and bacteria within us also shape our perspective, the same way that our perspective can shape the perspectives greater than ours, whoever you call that. Different religions, different customs, different philosophies, all point to some higher existence. However, we don't usually look at it as all the same framework, especially an objective and philosophically objective framework. And again, this framework isn't the end all be all, but it is a way for everyone to get closer to what reality really is. Science isn't really reality, it's just the best way to understand how reality functions and understand the mechanisms. The pattern is simple, the implications are limitless. Information becomes relationship, relationship becomes structure, structure becomes experience, experience becomes understanding, understanding becomes the next universe. In the end, we are not separate from the universe, we are expressions of it. We are how it learns, grows, and remembers. And I would like to end by showing you the book that gave me a lot of these ideas. However, it didn't give me all of these ideas to make this video, called The Cosmic Code, Quantum Physics as the Language of Nature, written by Heinz Pagels. And Heinz Pagels used to love going on these trips, these mountaineering trips, climbing up snow-capped mountains. And I just wanted to show two pictures here of a hike I went on at Rocky Mountain National Park up to Sky Pond, which you can see right here, frozen. And it was a beautiful hike going up there that me and my wife took. And I just want to show, this is just a way to show how important it is to embrace your imagination and try to accomplish anything you want in life. So if you want to go climb a mountain like I like to do or like Heinz Pagels like to do, and be fearless about it, because you are the universe trying to explore, learn, and figure more things out so that the future can be created with that wisdom, and more emergent patterns will keep on forming that are more beautiful than we can imagine. So if you like this video, please like and subscribe, and you have a wonderful day.